Freshwater. Today, my job is to convince you that mushrooms are here to save the world. Why do I think this? They've done it before. 350 million years ago, a global crisis was looming. Giant trees ruled the Earth, and the source of their power was this complex molecule known as lignin. However, once they fell, they remained. The bacteria and fungi that can degrade lignin had yet to arrive, and the planet was drowning in trees. Eventually, a hero, in the form of a mushroom named Agaricomycetes, that evolved to break down lignin. The trees could be decomposed, the soil was replenished, and life on Earth flourished. This is essentially a process that today we call mycoremediation, which is when we use fungi to clean up our environment, which is pretty topical because right now New Zealand has a big environmental problem in its freshwater lakes and rivers. A 2013 study found that New Zealanders rate water quality as the country's most serious environmental issue. Their concern is well-founded, with 1/3 of our lakes and rivers deemed unsafe for swimming. The primary culprit is dirty dairying, cow effluent leaching into freshwater ecosystems, bringing with it high levels of nitrates as well as bacteria and parasites. Now, I don't intend to single out the dairy industry here, but I just took this quote directly from the latest edition of Lonely Planet. This has begun to negatively impact our tourism industry. New Zealand's international reputation has been damaged. The 100% pure claim has been called into question. And this story has been all over the media, including the crisis in Havelock North last year, when bacteria got into the town's water supply, making 5,000 residents ill and causing 3 fatalities. The inquiry into the fact said that the cause was sheep feces leaking from nearby paddocks. So, we need to begin looking for innovative solutions. And this is where fungi come in, because fungi are the main force in nature for recycling nutrients and making ecosystems fit for life. I've called them unlikely heroes because although fungi are these amazing powerhouses of decomposition, they often get overlooked in mainstream science and technology. So, when I say fungi, you probably think of something like this. It's great on toast, but the world of fungi is much more diverse than just what makes it to your table. As scientists, we're more concerned with a structure called mycelium. Mycelium are the fine strands that grow through materials and consume nutrients. It's only when mycelium wants to reproduce itself that it fruits into what we know as a mushroom. And mycelium is tiny. It's about 1 micron across, which is 1/5 as big as a red blood cell. 1 cubic inch of soil can have about 8 miles of mycelium within it. So mycelium grows out like this vast web across all sorts of different substrates. And like your stomach makes enzymes to break down your food, the mycelium makes enzymes that break down whatever it's growing on, kind of like an inside-out stomach. And we can harness this and use it to clean up all sorts of pollutants, from pesticides to petroleum spills. And this is significant because it means that fungi break these down at the molecular level, rather than just removing them to be dealt with elsewhere. Some radical mycologists have even trained fungi to break down cigarette butts and diapers and all sorts of other weird and disgusting things. So, the science is pretty cool, but how do we apply this to New Zealand's freshwater problem? There are 3 main issues plaguing our lakes and rivers. Sediments. When plants are removed from areas adjacent to streams, called riparian areas, the banks erode and the dirt and silt flows into the water. Nutrients. Nitrogen largely comes from livestock urine, while phosphorus comes from fertilizers. Excess nutrients in freshwater lead to algae blooms, which causes dead zones, and this impacts biodiversity and the fishing industry. And bacteria, which is largely E. coli from cow feces. E. coli and Campylobacter were responsible for the incident in Havelock North. The processes that fungi evolved to break down lignin are actually applicable to a huge variety of compounds. Lignin has chemical substructures, which are very similar to many agricultural fertilizers and pesticides. Other species of fungi, like the oyster mushroom, secrete enzymes which kill bacteria like E. coli and Campylobacter. Aside from killing bacteria, fungi can form symbiotic relationships with bacteria where they work together to break down certain contaminants. It also glows into plant roots, which we see here is called a mycorrhizae, And this greatly increases the plant's ability to uptake nutrients and resist disease. This means that we can pair mycelium with riparian planting projects like are being recommended by Dairy NZ as a solution to make them much more effective. So I've been obsessed with fungi for a long time, but it's not often that I get excited about fecal bacteria. This study makes me excited, though. So what they did was they built these two big biocells. You can think of a biocell as a fully contained garden that has a water inflow and a water outflow, kind of to simulate a wetland environment. And what they did was they planted each one exactly the same, but for one, they inoculated it with mycelium, and the other was left as a control. And then they spiked E. coli into the water inflow and measured the levels of bacteria in the outflow. What they found was that the control cell removed 66% of the bacteria, while the fungi cell removed 90%. Sorry, that got cut off. Even better than that was the stress test, where they basically dumped a bunch of dairy lagoon waste into the cell to see what would happen. So you can see these are the two cells going about remediating. The green is the control cell, the plant cell, and the purple is the fungi cell. And the red arrow is when they added a huge amount of bacteria. And there's a short lag time, and then the control cell just skyrockets, but the fungi cell barely peaks at all. And this indicates that although mycelium is better than riparian planting alone, it really excels in emergency events such as floods when effluents get washed into rivers. Remembering Havelock North, that happened directly following a period of heavy rainfall. And this could become particularly important looking forward at our future with climate change, when flood events are likely to be more frequent and severe. So, what would a mycoremediation industry actually look like? Well, currently things are in the proof of concept phase. We need more research and investment to commercialize and develop the technology. But the implications are pretty exciting. Living biofilters. In 2013, an EPA study grew mycelium across mesh mats. These were used in bacteria-rich stormwater runoff and proven to be able to remove E. coli from running water. A secondary benefit is that because mycelium is so tiny, remember it's 1 micron, it's able to directly filter solid sediments out of water, essentially forming a high-density, nanoscale, antibacterial, biodegradable filter. There's also the opportunity to genetically modify fungi to secrete specific enzymes that we desire. Rise of technologies such as CRISPR open up the possibility that we can design fungal mutants that are better adept to treat our wastewater and more environmentally resilient. And we could also establish remediation as a service for landowners or farmers who want to address their environmental impact. This would probably look similar to the biocells that we saw earlier and would involve a commercial scale production of high quality inoculated materials such as wood chips to be used in riparian planting. There have been some studies like this already done in New Zealand. A 2006 study at the University of Waikato attempted to use mycelium to remediate a site contaminated with PCP. PCP is a pesticide which was used here until 1988 and is highly toxic. They found that using white rot fungi, the decrease in the compound was greater than 90%. Interestingly enough, the two species that worked the best were New Zealand natives that were both harvested from the trial site. There's another study which has been running in Wellington since 2009, over in Mount Victoria, where they're trying to remove DDT from the contaminated site. DDT is an insecticide, which has also been linked to cancer and infertility, even in low levels. Their tests in 2010 showed that DDT was removed 65 to 80% through the use of mycelium. So what are the benefits of using mycelium? Well, it's a natural technology. This means that there's no secondary waste products or toxic byproducts. It's generally considered harmless by the public and easily accepted. And the biosecurity hazards are pretty minimal, as the type of fungi used in mycoremediation are benign to mammals and often have positive environmental impacts. It's applicable across a huge variety of compounds. I've focused here on pastoral farmland and waterways, but the infrastructure for this can be used for a vast variety of projects and contaminants. Already, a large proportion of our Antibiotics are sourced from fungi, and as we approach antibiotic resistant, we need to start looking for other options. So extending our skills and knowledge base here will almost certainly lead to secondary benefits in other areas. And it's economical. This is data from a microremediation project where they were trying to break down petroleum spills. You can see there's microremediation on the right here. It's averaging about $50 a ton and is much less expensive than other methods of remediation. Still, this technology does face its challenges. It's still in its infancy, and while it's shown success in lab trials, moving out into the fields can bring up all sorts of unexpected complications. It's one thing to say that remediation is possible, but in the field it faces competition from other fungi or varying conditions of humidity and temperature, and these can all affect how well it performs. I believe that is something that we can address through research and technology. There's also the potential for other competing technologies. Right now, remediation also happens through bacteria and plants, and these all compete for similar market sectors. Also, as New Zealand moves towards more a knowledge economy, we'll see rise in technologies like synthetic meats and milks. These are disruptive technologies that could kind of rip the rug out from under us and solve our freshwater crisis in ways that we can't yet imagine. There's very little social drawback here. Meanwhile, the social benefits are fast. Remediation of our rivers mean that they're available for swimming and drinking and minimize freshwater hazards. They protect tourism and farming. Tourism has recently overtaken dairy farming as New Zealand's largest export earner. Equipping farmers with the tools to address their environmental impact allows them to care for their land and our health without sacrificing their livelihoods. It establishes a new industry, which is commercially viable and creates jobs across many layers. Mycology is one of the youngest natural sciences, and there's a plethora of things that we don't know. New Zealand has 22,000 native species of fungi, and only 1/3 of these have been documented. Finally, I believe that we have an obligation to protect the beauty and biodiversity of this amazing country. We have the tools here to heal our lakes and rivers, to leave them healthy for our children and for many generations to come. And to do this, we're putting mushrooms on the table. Thank you very much.
Thanks, Cassandra. If we have algal blooms at the moment as a result of overnutrient, would there not be such a thing as a mycelium bloom?
No, not particularly. Algae really thrive in freshwater, and they thrive in water ecosystems. That's where they grow, but mycelium isn't able to survive, typically, in conditions of that high humidity. Generally, it's hard. It's not the most simple thing to create mycelium bloom. We have to intervene and do it ourselves.
I could hear you physically trying to avoid saying the phrase fungal mutant, but nevertheless, you couldn't find an alternative. Do you think that what we need exists already, or will we need to genetically modify something?
I think it could go either way. We already do have plenty of species that can do what we want to do. I think that GM is probably part of the future of this because it is such a powerful technology. It allows us to do so much more and to make it better and more resilient.
But the fact that it would be so close to what we are trying to protect makes the risk factor quite high, doesn't it? It may prove to be toxic in some way to the wildlife and the environment that we're trying to preserve.
Do you mean if we decide to modify it?
No,
Or?
either, anyway, whatever.
Generally, I mean, there are species of fungi that are pathogenic and that they are harmful to animals and stuff, but for the species that I've talked about, the ones that generally do kill bacteria or consume nutrients, they're good for us. Like oyster mushrooms you can eat. Any of these, at least the studies that I've read so far, you can consume them afterwards, even if they're grown in cow feces, provided they aren't grown on radioactive waste or, yeah.
Well, your suggestion that the mycelium would remove DDT, does that mean it absorbs it and itself becomes polluted, or it breaks it down into a harmless substance?
It breaks it down. I would still want to see a lot more science before I would eat DDT mushrooms, but it does break it down.
Thank you.